quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. But what are quasars? Where did they come from? And most importantly, are they dangerous to us? Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of time. Usually, there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body, which is 4 million times heavier than our Sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry. Even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small, and is too tiny to eat an entire galaxy. So it's more like a cosmic vacuum cleaner that sucks up stars or gas that gets too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own Sun. Now, imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls toward the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them, even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange. Radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. And that's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. You could call them quasi-quasars. For example, they kind of defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes, they also help us confirm the laws of physics. Now imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago, when the Earth was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age. And that's where quasars come in. They're like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef, or a leaf blower, you pick. For example, let's take galaxy mergers. Here are two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shock waves that trigger the birth of new stars and even supermassive black holes. And this is where the quasars come into play. Some quasars may be born during these galactic get-togethers, and thanks to this, they help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kind of like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? There's still a lot we don't know about these mysterious objects. In 2007, a team of astronomers made an astonishing discovery: the first true binary quasar. Basically, this means two huge quasars spiraling around each other. What's more, they were hiding in plain sight. For years, scientists had known about this radio source, but had never realized that it actually comes from one lovely couple. The astronomers also estimated that this pair may have a mass of about 100 billion suns. They're super distant, though, at an astounding 12 billion light-years away from our blue planet. Overall, quasars are a fascinating and complex phenomenon that continues to baffle and intrigue scientists. They may be cosmic galaxy eaters, but they're also playing a critical role in the formation and evolution of the universe. And who knows, maybe one day they'll become one of the keys to unlocking the mysteries of our universe. Oh, you crazy quasars.
Space is a dangerous place. It seems like wherever you go, something tries to get rid of you. So what if you wanted to go up there without a spacesuit? What's good is that your body probably wouldn't explode. Your skin is strong and stretchy enough to deal with all that pressure. You wouldn't freeze right away either. In space, the only way for your body to lose heat is through radiation, which happens very slowly for a relatively cool object like a human body. You would eventually get cold, but it would take a while, or your fluids would evaporate. Keep your eyes closed if possible. Okay, the air would be the first emergency problem here. Your brain wouldn't be able to get oxygen, so you'd pass out within 15 seconds, and within 3 minutes your brain would shut down forever. If someone rescued you within the first 30 seconds, you might only have some bruises on your skin from all the pressure changes. Hopefully you didn't try to hold your breath before they catapulted you out there though. In that case, the air in your lungs would cause them to rupture, which again wouldn't be a happy end. But here's a spot where no one would be able to save you: the center of the galaxy. Each galaxy has a supermassive black hole at its center, and these are even worse than you might expect. They eat up a bunch of matter and release an enormous amount of energy. The largest of these gobblers and the hungriest among them are something we call quasars. Well, to be precise with the relations here, quasars actually contain supermassive black holes that eat everything in their way. And these quasars are some of the most energetic space objects that we know about. When something falls into a quasar, it gets really hot and shoots outward at very high speeds because of the strong radiation force. Quasars can deceive you if you try to observe them through a telescope because you might think you're looking at stars. Astronomers also named them quasi-stellar radio sources because the signals were coming from one place, similar to how it goes with a star. But quasars, of course, have a stronger light. They can shine much brighter than a galaxy with billions of stars. But this same radiation that makes them so bright is not such good news for the galaxies where they're located, because these guests are not very polite and they're slowly ripping them apart. Okay, maybe not that slowly. As a black hole eats matter, hot gases circles around it and produces very intense radiation, which then creates a quasar. Scientists use the famous Hubble Space Telescope to study 13 insanely powerful quasar outflows of radiation. This energy can travel at speeds over 40 million miles per hour and reach temperatures of billions of degrees. One particular outflow of radiation they studied got faster and went from nearly 43 million miles per hour to about 46 million miles per hour in only 3 years. The energy these outflows carry is several hundreds of times stronger than all the light our entire Milky Way galaxy emits. And all this hot gas is moving so fast that it can really cause a lot of damage to the host galaxy. It rushes through the galaxy like a massive tsunami, faster than anything we've previously discovered in space. At the same time, it's pushing apart all the potential material that could get together and form new stars. In just 1 year, this quasar wave can push away as much matter as hundreds of suns and create spectacular fireworks. I mean, the light show would be cool, but that seems like an awful lot of wasted material. These things we're discovering can really help us answer the question that's been bothering us for such a long time. Why do big galaxies stop growing after they reach a certain mass? No wonder when the quasars don't even allow new stars to be born. How rude! I mean, a black hole itself can't destroy the whole galaxy. When a star gets too close, a black hole will tear it apart with its strong gravity. This creates a lot of energy and a bright flare too. And even though we can't really see a black hole itself, scientists can at least study these flares. They can measure their energy more accurately than ever before because they look at how the surrounding dust absorbs and re-emits the light from the flares. It's actually similar to how echoes work. Scientists have also used NASA's Chandra X-ray Observatory to study more than 100 galaxies and realized these black holes are consuming thousands of stars, so they could gain more weight. There are different types of black holes. We call smaller ones stellar mass black holes. They're about 5 to 30 times the mass of our Sun. On the other end of the scale, there are supermassive black holes that nest in the centers of large galaxies and weigh millions, or even billions of times the mass of the Sun. And recent research tells us there are intermediate mass black holes, which lie in between the two extremes. And it seems these intermediate black holes could be small black holes that had been eating lots of stars, becoming bigger. The special buffet a black hole just can't resist is when there's a dense cluster of stars in the center of a galaxy. Yum! So yeah, black holes are mean fellas, but there's still no way they could eat a whole galaxy. A black hole's gravity is just not strong enough, unless there's a quasar around, making its force stronger. Don't worry though, quasars are usually billions of light years away from us. That means we see them as they were billions of years ago, because light takes time to travel. And light years represent the amount of time necessary for that. It's great that we can study quasars, not because they're pretty cool, terrifying, but still cool, but because with their help, we can learn more about how our own galaxy formed and developed. Quasars are part of a larger group of objects called active galactic nuclei. This family tree also includes Seyfert galaxies and Blazars. These are not as awesome as their cousins, but okay, we'll give them a short introduction. Seyfert galaxies may look normal in regular images, but they emit a lot of infrared radiation, radio energy, and X-rays. Basically, they're similar to quasars but release less energy, and they have supermassive black holes at their centers too. Copycat. Blazar and quasar sound pretty similar, huh? Still, they're a bit different. The story of a blazar starts in a familiar way. At the center of a galaxy, there's a giant black hole surrounded by a disk of dust, gas, and debris that spins really fast. As the material in the disk falls towards the black hole, its gravitational energy can end up being converted to light. This makes the center of these galaxies very bright, and we call them active galactic nuclei. Some of these active galactic nuclei are not fine with just shining bright, so they shoot out jets of material that nearly reach the speed of light. This is a quasar. But when a galaxy happens to turn so that the jets point towards our home planet, it's what we call a blazar. And yes, it's like Earth is staring down the barrel of a cannon. Quasars and blazars emit jets of particles pointing towards us or in our direction. Scientists believe Seyfert galaxies are different because they emit jets pointing away from us, which is why it's harder to detect them. These jets from blazars can release particles with lots of energy that we call neutrinos. A couple of years ago, scientists discovered a single neutrino that traveled from a supermassive black hole in a blazar located about 4 billion light-years away. This was so exciting because we've captured neutrinos from only 3 cosmic sources so far: our Sun, a supernova, which was a powerful explosion that happened in a nearby galaxy in 1987, and now from the blazar.
In the heart of the galaxy, there lies a mysterious object, the likes of which no astronomer has ever seen. It streaks across the sky like a shooting star on caffeine. So, what is this mysterious blob? And how is it related to the black hole in the center of our galaxy? Let's find out. This thing is called X7. It's the mysterious blob that's been hanging around our galaxy's supermassive black hole for decades. Some even say it's been lurking around there for, like, hundreds of years. We know a few things about X7. For example, it weighs around 50 times as much as Earth. It may sound like a lot if you're an Earthling, but in space, that's like a tiny drop in the ocean. X7 is also moving pretty fast, at speeds of up to 700 miles per second. That's faster than you trying to catch the last slice of pizza before your roommate gets to it. But what in the world is this thing? A magic star we've never seen before? An extraterrestrial spaceship? Well, there are some theories connected to the blob's future tragic fate. Unfortunately, X7's days are numbered. Right now, it's on a 170-year-long elliptical orbit around the supermassive black hole at the center of the Milky Way. But it's not going to make it that far. Each year, it's spiraling closer and closer to the black hole. In just a few years, it will become spaghettified. Yes, that's a real scientific term. And finally get sucked in, never to be seen again. There are supermassive black holes in the centers of all galaxies, including our very own Milky Way. These black holes are so massive that they warp space-time, causing nearby stars to orbit around them at incredible speeds. They serve as cosmic vacuum cleaners that suck in anything and everything that comes close enough. The black hole in our galaxy is called the Sagittarius A star. Sounds like the name of a fancy Hollywood celebrity, doesn't it? But this celestial object is far more impressive than any mere mortal. It's about 4 million times more massive than our sun, which means it could probably eat our entire solar system for breakfast. But don't worry, these black holes may seem really scary, but in reality, they're too small to compete with an entire galaxy. They'll just suck in a couple of the nearest stars, and that's all. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, it would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the Accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome. You're in your galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The star wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo Cluster. This is the one that scientists studied and came across the star wrecker. The nearby Virgo Cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of, currently. Who knows what else is out there? The Virgo cluster is also unusual, as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the sixth brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo Cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, EHT. It was announced excitedly to the world in 2019. In March 2021, the EHT collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo Cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies, or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the star wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment was inspired to begin a lifelong quest based on a single question, perhaps the ultimate of all: what's out there? Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune. The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
Black holes are ruthless. They can swallow asteroids, comets, planets, and even stars. But can a black hole consume the entire universe? Almost any black hole was once a massive star that collapsed in on itself and became incredibly dense. Black holes have immense gravitational pull. Even light can't escape their clutches. The idea that a black hole can swallow the universe is based on a common misconception. People often think that black holes work like vacuums, pulling space inside. But that's not the case. Black holes can only swallow stuff that is extremely close, usually space objects venturing into their event horizon. That's a black hole's point of no return. Once you cross this border, there's no escape. The event horizon for a black hole with the mass of our sun could extend a mere 2 miles. If a tiny black hole had a mass of our planet, its event horizon wouldn't stretch for more than a couple of inches. It would be the size of your thumb, no more. But a black hole's gravity still affects the stars and planets surrounding it. It might make them orbit, just like the black hole at the center of the Milky Way galaxy does. But the hole doesn't swallow them. If our sun somehow transformed into a black hole with the same mass, which is highly unlikely, Earth wouldn't feel any difference in the gravitational force influencing it. Our planet wouldn't change its orbit or hurtle toward the newly born black hole. Of course, it would get very dark and freezing cold, but being pulled inside a black hole wouldn't be a concern. Plus, most black holes are quite small. A black hole can only swallow a star if the said star is aimed almost directly at the black hole. Theoretically, it might happen. But according to space experts, for the sun to get swallowed up by a black hole at the center of our home Milky Way galaxy, a truly enormous amount of time would be needed. After all, the star's orbit would need to line up with the black hole in a very precise way. Even the largest black hole in the universe that we know about, a space titan called Ton 618, seems to be near the theoretical limit of how large black holes can grow. This limit is determined by the fact that black holes release tons of radiation while developing. This radiation heats up and ionizes the matter surrounding the black hole, which makes it more difficult for the dust and gas to cool down and fall into the black hole. As a result, it slows down the rate at which the black hole can feed. We can probably say that this self-regulation stops black holes from gobbling down entire galaxies, let alone the whole universe. And we shouldn't forget about the expansion of the universe either. Objects in space move farther apart, which makes it less likely for them to collide or get captured by a black hole. If a black hole were to consume the entire universe, it would require a tremendous shift in the direction in which space seems to be moving. So, you don't need to worry that one day, our whole world will disappear inside a huge, universe-swallowing black hole. Unless, of course, the universe is already inside a black hole. I'm not kidding. There's a theory that we might be living in a black hole. Think about this. What if a black hole already engulfed us long ago? Surprisingly, some physicists deem this theory pretty plausible. For example, Dr. Nikodem Poplawski, a theoretical physicist from Indiana University, states that everything that a black hole swallows may turn into a new universe inside the hole or on the other side of it. So who knows? Perhaps our universe used to be quite a different place until it got pulled into a black hole.
So you're driving down the highway, and an 18-wheel tractor-trailer is coming up fast behind. You've got to change lanes. You look in the mirror. Is there enough space? And you notice the words on the mirror. Objects in the mirror are closer than they appear. No kidding! Well, it's the same with the Milky Way galaxy. There's another galaxy headed this way, and like the tractor-trailer, it's closer than it looks. The Andromeda Galaxy, or M31, as it was labeled originally by Charles Messier in his catalog of 110 fuzzy objects in 1774, is now officially named NGC 122, that's New Galactic Catalog 122. A spiral galaxy larger than the Milky Way, the Andromeda Galaxy is so big and so close that you can see it without a telescope. In fact, it appears with the unaided eye half as wide as the Moon. It's estimated that the Andromeda Galaxy contains 1 trillion stars, compared with the Milky Way's estimated 300 to 400 billion measly stars. To see the Andromeda Galaxy, you must allow your eyes to become dark adapted. This might take about 10 minutes while your pupils dilate to take in as much light as possible. M31 is best seen from late summer through winter, when the great square of Pegasus the Winged Horse is overhead. Draw a line across the great square diagonally upwards from the lower corner star, then go a little further beyond the square. There it is, but you still won't be able to see how big it is unless you peek at it from the corners of your eyes. If you stare straight at it, the galaxy will tend to fade away. You must use your peripheral vision to see how big the Andromeda Galaxy appears. Peripheral vision, or averted vision, allows you to see light more sensitively at night, but without color. Sailors have used averted vision for centuries to see faint lights out on the ocean or on land. Aristotle used averted vision to observe star cluster M41 in Canis Major, as he described in his book Meteorologica. In a telescopic photograph, the Andromeda Galaxy appears 6 times wider than the Moon, because with the unaided eye, we can only see the bright center of the galaxy. A telescopic photograph shows how massive M31's spiral arms really are. And this beast of a galaxy is headed our way. We are looking at a future massive collision of galaxies of, well, galactic proportions. When that happens, humanity may need to relocate to another galaxy to inhabit. Perhaps we'll go to the Pinwheel Galaxy in the asterism of the Big Dipper. How do we know the Andromeda Galaxy is moving towards us? With a tool called a spectroscope. After the camera, the spectroscope is the most important attachment to a telescope. Oh, except for the human eye. Our eyes only see light. You don't have this big horse in your eye. You only have the light being reflected by the horse in your eyes. The same with space. We only see the light coming from there. So, if we are going to understand space, we need to understand light. And that was not an easy task for astronomers of the 19th century. The invention of the spectroscope was a big breakthrough in understanding light coming to Earth from space. With a spectroscope, astronomers can tell which direction objects in space are moving, as well as which elements are making the light. When you hear an ambulance approaching, you hear the siren getting louder and higher, and when it passes you and goes away, you hear the siren's sound get weaker and lower. The change in pitch frequency depends entirely on the motion of the source. This is called the Doppler effect, after the Austrian physicist and mathematician Christian Johann Doppler, who first explained the effect in 1842. The ambulance siren is not changing its volume. The sound waves are being compressed as it is approaching and stretched as the ambulance recedes. The spectroscope shows that light waves show the same Doppler effect as sound waves. They are compressed as the star or galaxy is approaching us and appear stretched when it is receding. Therefore, the light from an approaching galaxy will appear slightly bluer, the blue shift, a slight increase in frequency, and the light from a receding galaxy will appear slightly redder than normal, or red shift, a slight decrease in the light's frequency. In 1929, Edwin Hubble, after whom the Hubble spacecraft is named, published his spectroscopic study of 46 galaxies, the light from all but one of which was redshifted, moving away. Hubble's study provided the first evidence that the universe was expanding. The farther away a galaxy was from the Milky Way, the faster it was moving away. This was also the first evidence that the universe began with a Big Bang. The one galaxy whose light was blue-shifted, moving towards the Milky Way, was M31, the Andromeda Galaxy, the closest galaxy. 250,000 miles per hour seems a pretty high speed at which to have a collision. That's the speed spectroscopic measurements of the blue shift of Andromeda indicate. It's going to be a big mess when it happens. But when is it going to happen? To determine when the two galaxies will collide, We need to determine the distance between them, and for that, we need, boom, supernovas. Type 1A supernovas are what are called standard candles. Just as we know how bright a candle shines, we know how bright a Type 1A supernova shines, its absolute magnitude. A Type 1A supernova appears when a white dwarf collapses under the pressure of all the gas it has been gravitationally slurping from a companion star. Looking at the Andromeda Galaxy and measuring the apparent brightness of a supernova in the galaxy, it is possible to calculate its distance away from us. Because the intensity of light dims inversely with the square of its distance away, which is called the inverse square law, by comparing the apparent brightness of a supernova in the Andromeda Galaxy with its absolute brightness, well, we get an approximate distance of 2.5 million light-years. Since 1 light-year is approximately 6 trillion miles, and the Andromeda Galaxy is 2.5 million light-years away, even though it is approaching at the speed of about 250,000 miles, we have about 4 billion years before the big collision. So you can wait until after lunch, maybe dinner, to start packing. As an aside, if we see the Andromeda Galaxy as it was 2.5 million years ago, and it has been moving toward the Milky Way all this time, how big in the sky would it appear now? Quite as big as that tractor trailer in your rearview mirror. But do we really have 4 billion years before the galaxies crash? There are several other factors to consider. The minor galaxies that are gravitationally linked to both the Milky Way and the Andromeda Galaxy will be swallowed up by their host galaxies. Considering the lopsided mass distribution that will result, the galactic collision of the Milky Way and Andromeda will be affected. Some scientists are saying it won't be a direct hit, but more of a sideswipe. And then there's the galactic halos of each galaxy. Here's what Project Omega has found out about the halo of stars and gas surrounding the Andromeda Galaxy. Using the Hubble Space Telescope, researchers were able to observe how the light from bright distant quasars were being absorbed by the mostly invisible gas around the Andromeda Galaxy. Look at the results. Notice M31 in the center. If the same is true of the Milky Way, and there's no reason to think it would be different, then the halos of the two galaxies are touching now. The collision has already begun. There is also a question about what effect the dark matter clouds around each galaxy might have on an impending collision, or are having now. But enough of speculation. In 4 billion years, the Sun will have increased brightness on its way to becoming a red giant star. And humans will have already found another galaxy to inhabit. Happy traveling, dear humans!
Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's Great Red Spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the near future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level parallel to the ground so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be on edge in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mentioned the presence of a giant spot on Jupiter too. If it was the same great red spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 300 to 400 mile-per-hour jet streams. But like any other storm, the Great Red can't keep raging forever. It's been shrinking for a long time. In a decade or two, it's predicted to turn into GRC, the Great Red Circle, and who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 35,000 miles across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 10,150 miles, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet sitting over 3 billion miles away from Earth in the region of the Kuiper Belt drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving further away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects, just like the Sun, they were still sure that stars went through major changes extremely slowly, on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the Sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they're hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggest that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate. But VASCO is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs, and neutron stars or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and its and our future.
Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage, recorded by scientists, may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you, a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, muumuus. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. Ring-a-ding-ding. The Milky Way is one of the biggest mysteries out there, literally. It's hard to figure out how big our home galaxy is, and one of the main reasons is because we live in it. Think of it as walking around a mall. You can tell it's big, but you can't be certain until you actually see it from a bird's-eye view. The Milky Way consists of billions of distant stars that look like a string of lights from afar. So you just need to measure the distance between these stars and voila, you have the answer. Not really. I might have forgotten to mention opaque clouds of dust blocking your view. Some scientists were stubborn enough to run computer models of how galaxies form and evolve. There's a halo around our galaxy, so the scientists wanted to see if there was some sort of a dead end in the Milky Way. They found out that the Milky Way spreads for 100,000 light-years away from its center. It likely means that the entire galaxy is around 200,000 light-years across. The problem with this estimation is that halos don't tend to have some final border since they simply fade away. It's like pointing a flashlight and trying to see precisely where the light ends. In 2013, the Hubble Space Telescope captured an image of something 25 million light-years away. It turned out to be a spiral galaxy, later called ESO 3738, with at least 7 other galactic neighbors. And this galaxy is as thin as a pancake, a very shiny pancake. The telescope also took a photo of another galaxy cluster 65 million light-years away. It was called IC 335. It's another glorious glittering pancake floating in the vastness of space. The images the telescope took aren't the most accurate. It's hard to tell what exactly you're looking at. These disk galaxies have lots of dust clouds that can stretch for hundreds of light-years across. They're mainly located near the centers of galaxies and are invisible in regular light, but they can be detected with the help of a blue filter. Anyway, this IC 335 galaxy is an oval disk with huge clouds of gas and dust. This means stars constantly appear there. But not all galaxies create stars. A galaxy is born as a giant ball of slowly rotating gas that is steadily collapsing in on itself. As it starts spinning faster and faster, the pancake shape is formed. Ooh, pass me the syrup. It's like spinning pizza dough in the air after rolling it into a ball. The topping is stars, and the sauce is clouds of dust and gas. Are you getting hungry like me? Some galaxies can lose their gas and dust if they become part of a galaxy cluster. Then all these mini-galaxies orbit their common center of mass, with gas separating them. When a disk galaxy dashes through them like a speeding train, the pressure can blow away this dust and gas. From far away, it looks like you're staring at a DVD you're about to play. But if you traveled millions of light-years to get a closer look, you'd see a dim disk filled with stars. You wouldn't even be able to tell you're inside it. You'd also see a bright blob of dust left by the red giants in the middle of the galaxy. Red giants are massive and very bright stars with low surface temperatures. But the images of these galaxies don't actually show us their real color. Cameras make up some of these hues so that you don't have to look at something fuzzy or grainy. People don't actually know the real colors of distant galaxies. Our galaxy has a lot of gas inside, like me, so we don't need to expect our home to dry up anytime soon. In fact, the Milky Way still produces new stars, around 7 a year. But some galaxies fade out when they can no longer create stars. In the industry, they call it strangulation, and it happens when galaxies run out of gas, which means there's no more new material that can be used for star making. Gas and dust aren't the only things you can find in a galaxy. Just like a magician pulling a rabbit, flowers, or other things out of their magic hat, galaxies have other surprises, like planets, those balls of matter spinning around themselves and around other things. Well, technically, planets are far from being perfectly round in shape, but they aren't also flat like spiral galaxies. It's mostly because of gravity. Its force is so strong that a planet pulls everything towards its center, taking the shape of a sphere. In the process, all the edges and anything else that might stick out gets smoothed out. But the smaller a space body is, the less round it is. Take a comet. It doesn't always have a smooth surface. It's small, and therefore, its edges are rugged and pointy. Given the size of Earth, it's safe to say the gravity is strong here compared to that of the Moon or any smaller-sized space object. And because of our planet's constant rotation, there's an outward bulge on Earth. This tug-of-war between the gravity pulling inward and the planet's spin doesn't allow Earth to be a perfect ball. On top of Earth not being a perfect sphere, the planet is also tilted. This design flaw is responsible for the seasons we have. This tilt could happen because millions of years after Earth was formed, it probably collided with a protoplanet, a large space body developing into a planet. Venus is unique because it rotates backward compared to the rest of its peers. If you were standing on Venus, the hottest planet in our solar system, you'd see the sun rise in the west and set in the east. But you'd have to make it on time to observe this phenomenon. A day on Venus lasts for more than 240 Earth days. For a long time, scientists believed that the sun's strong pull on Venus was responsible for such a long day. But new theory claims that Venus used to spin just like Earth and the rest of the planets. But at one point, it just flipped its axis 180 degrees. It doesn't mean the planet abruptly stopped halfway through the rotation and started to move backward. When theory suggests that a large comet or object struck the planet in the past. This might have caused it to change the direction of its rotation, but many scientists doubt this theory. If you observe the moon for some time, you may notice that it's the same face staring at you every night. The truth is that the moon does rotate, but very slowly. It takes our planet's natural satellite 27 Earth days to rotate around its axis. Plus, the moon rotates at the same rate that it orbits Earth. The side we always see is called the near side of the moon, and the side that's not facing us is, you guessed it, the far side of the moon. It also has the nickname the dark side of the moon. Uranus's rotation axis is 98 degrees relative to the plane of the solar system, which basically means that the planet spins on its side. For a while, scientists believed that a large object firing through space knocked into Uranus, causing it to tilt. But here's one problem. Uranus's moons are covered in ice. A collision so powerful that it made the planet tilt would have resulted in disrupting the moon's movement and their position. But they seem relatively untouched, and all the ice covering them is still intact. But any major changes happening with Uranus would have generated enough energy to melt the ice. Another reason for Uranus's strange position might be its rings. Yup, Uranus has rings just like Saturn, except they're lighter and fainter. Saturn's rings are mostly billions of chunks of ice and rock floating in orbit. Some particles can be the size of a pebble, while others can reach the size of a house. Wow. Other particles are broken up comets, asteroids, and moons torn apart by Saturn's gravity. If you observe the rings from afar, they look like colorful stripes made up of thousands of different streaks, but there are actually only 8 layers of rings. Uranus might have had rings that were just as glorious as Saturn's around 4.5 billion years ago. The balance between Saturn's gravity and its rings might be responsible for keeping the planet upright so that it doesn't tilt over. If Uranus had the same rings, they could prevent the planet from toppling over. The way to solve Uranus's tilting problem might be for the planet to get its rings back. They would help Uranus keep its balance. On the other hand, hey, we like it just the way it is.
The universe is a big, mysterious, and ever-changing place. But just like we have baby photos that show how we looked when we were little, scientists also have a baby picture of the universe. Only they were able to look 14 billion years into the past. How is it possible? Well, let's figure it out. Imagine winning the Oscars of science for a picture that shows the entire universe when it was just a baby. Scientists achieved this fantastic feat using NASA's Wilkinson Microwave Anisotropy Probe. To take this picture, they built a super cool satellite, launched it into space, and collected massive amounts of data about the universe. This image turned out to be a cosmic treasure trove. It helped answer some of the universe's biggest questions, but also revealed a few new mysteries. This groundbreaking data confirmed the standard model of cosmology and told us that our universe is around 13.7 billion years old. Plus, it showed us that the elements in our regular periodic table make up only a tiny fraction of the universe's recipe. To be honest, this is not quite a photo in the usual sense. Of course, we cannot actually photograph what happened so long ago. The picture we're talking about is called the Cosmic Microwave Background, or CMB for short. Now, the CMB is like a faint glowing light that fills up the entire universe in every direction. These clues that can help us understand how the universe evolved into what it is today. CMB is a super cool glow that fills up the entire universe. You see, when you look through a regular telescope, the space between stars and galaxies seems pretty dark. But with an amazing radio telescope, we can actually detect that this empty, dark space is filled with a super faint and even glow. This glow is all around us, and it's not coming from any star or galaxy. This is the cosmic microwave background, and it's strongest in the microwave part of the radio spectrum. The CMB is a frozen treasure, super chilly at around minus 455 degrees Fahrenheit. Bruh, that's colder than any winter you've experienced. This ancient light formed about 380,000 years after the Big Bang, which happened around 14 billion years ago. So we're looking way back in time. In the beginning, the universe was like a thick fog of incredibly hot plasma. It was almost 500 million degrees Fahrenheit. It was so hot that atoms couldn't even exist yet, only wild electrons and protons bouncing around like crazy. Because of this super hot fog, any light that tried to travel got scattered by those mischievous electrons. It was basically like trying to see through a foggy car windshield. But then, the universe started expanding in all directions, just like a cosmic balloon getting bigger and bigger. And it's still expanding today. As the universe did that, it began to cool down. When it turned 380,000 years old, it finally cooled enough for electrons and protons to come together. These tiny particles started to combine, forming mostly hydrogen atoms. When that happened, the universe finally became transparent, like a clear window. The moment of this magical transition is called the recombination epoch. Once the foggy era ended, the light could travel freely. The universe became like a vast playground for light to bounce around and explore. And, as you know, light has a certain speed, 186,000 miles per second to be specific. And it takes some time for light from distant places to reach us. So, in other words, the CMB is the oldest light in the universe. It's like a capture from a moment when the universe just started to become clear and transparent. As this light traveled through space, it went through all sorts of adventures, like the formation of stars and galaxies. Along the way, it lost some energy and transformed into microwaves, which our eyes can't see, and that can be detected only with special tools. Also, there are some tricky things that can mess with the data. For example, galaxy clusters. These are big groups of galaxies hanging out together in space. When the ancient light from the CMB travels across the universe, it encounters these groups, and these sneaky clusters try to leave their marks on the CMB. They distort the patterns in the ancient glow, like smudging the ink in the important ancient book. That's why scientists have to invent techniques and supercomputers to help clean up this mess and decode everything properly. Due to all this, the CMB isn't perfectly smooth. It has a few little bumps and patterns. These weird patterns make it unique, kind of like the universe's fingerprint. Scientists have been using amazing tools like the Cosmic Background Explorer and Wilkinson Microwave Anisotropy Probe to study these patterns. The COBE, our cosmic camera, took the first ever map of the sky in microwaves from 1989 to 1993. Why do we study it? Well, because the CMB can help us learn so much about the early universe. Stuff like how it expanded, how much normal matter and mysterious dark matter it had, and even the overall shape of the universe, and much more. We're basically playing detective with the cosmos, trying to decode the mysteries of our world by little clues and prints. What are the results? Well, awesome tools like the Wilkinson Microwave Anisotropy Probe helped us to learn more incredible facts. For example, we found out that we can actually only see 5% of the universe. Imagine the universe as a cosmic pie. Scientists learned that 68% of it is made up of something called dark energy, and 27% is dark matter. Only a tiny 5% is made of normal matter, the one that we, humans, can see. So, most of the universe is like this hidden realm we can't even imagine. We also found out what happened in the beginning of times. Picture the universe right after the Big Bang. It was so tiny, way smaller than a proton. Everything we see today was crammed into this itsy-bitsy space. The rules of quantum mechanics, which let weird and wild things happen, were in full swing back then. Matter and energy were like playful adventurers, borrowing from the future and disappearing into nothingness. Then, cosmic inflation happened, and the universe suddenly expanded like popcorn on a cosmic scale. It became a trillion times bigger than it was, creating waves of gravitational chaos everywhere. Some gravitational waves filled the baby universe like a sea, and their patterns left unique fingerprints on the CMB light. And all that learned thanks to the pictures of the CMB. Anyway, NASA has this awesome plan to study the universe's baby picture. They're going to use a really cool observatory called PIPER, which stands for Primordial Inflation Polarization Explorer. Imagine PIPER as a special space balloon that's going to fly up high in the sky from a place called Fort Sumner in New Mexico. It has two powerful telescopes that sit in a hot tub-sized container filled with liquid helium. This liquid helium is super cold at around minus 452 degrees Fahrenheit. But PIPER loves the chill because it's extremely sensitive. What is its mission? To learn all about the early days of the universe, right from its first baby picture. When PIPER is up there, it's going to look very carefully at the CMB, trying to find some hidden patterns that hold the secrets of how the universe grew and changed over time. This spy with a magnifying glass will be examining 85% of the sky. PIPER's launch is scheduled for late September. You can even watch the exciting balloon-filling action live on the Columbia Scientific Balloon Facility website. It's going to be out-of-this-world fun. So, the cosmic microwave background is like a time-traveling storyteller, giving us valuable clues about the universe's incredible past. Isn't that awesome? Space is full of surprises, and there's so much more to discover. Keep your eyes on the stars, and who knows what else we'll find out there.
Ah, space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now. and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's going to take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus Galaxy Cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds, so moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brrr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows? Maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk? Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist. It's just that you can't hear them. There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere, The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of negative 418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads. And we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with him on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops, well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the moon, the side that we never see because the moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting, too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes. Our Sun is an average-sized star, and still, it could fit 1,300,000 Earths. The star is also 333,000 times as heavy as our planet. NASA has translated radio waves created by planets' atmospheres into audible sounds. That's how astronomers found out that Neptune sounds like ocean waves, Jupiter like being underwater, and Saturn's voice resembles background music to a horror movie. Here on Earth, it's bebop jazz. No, I made that up. The sun's surface is scorching hot, but a bolt of lightning is 5 times hotter. Earth gets struck by 100 lightning bolts every second, which results in 8 million lightning strikes a day and around 3 billion a year. Ooh, shocking. If you manage to go to the moon one day and see fresh footprints, that doesn't mean there's someone else there with you. Footprints or similar marks can last for 1 million years over there. Because the moon doesn't have an atmosphere, there are no winds, not even a breeze, that can slowly erase those footprints. Astronomers have found the largest hole we've ever seen in the universe. It's the giant void that spreads 1 billion light-years across. They found it accidentally. One of the research team members was a little bored and wanted to check how things are going in the direction of the cold spot. That's an anomaly in the Cosmic Microwave Background Map, or CMB for short. It's a faint glow of light that falls on our planet from different directions and fills the universe. It's been streaming through space for almost 14 billion years as the afterglow that occurred after the Big Bang. So you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort. Rather significant, to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than the Sun. Their event horizon is wide, and the gravity doesn't change as quickly. So, the force you'll feel at your heels and at the top of your head will be about the same. And you can go all the way to the heart of the black hole. This myth is busted. If you watch a very touching movie in space and start crying, your tears won't run down. They will gather around the eyeballs. Your eyes will get too dry, so you'll feel like they're burning. Any exposed liquid on your body will vaporize, including the surfaces of your tongue. Speaking of burning, that's one thing fire can't do in space. Fire can spread when there's a flow of oxygen, and since there's not any in space, well. Once they explode, stars aren't supposed to come back to life. But some of the stars somehow have survived the great supernova explosion. Such zombie stars are pretty rare. Scientists found a really big one called LP 40-365. It's a partially burnt white dwarf. A white dwarf is a star that burned up all of the hydrogen, and that hydrogen was previously its nuclear fuel. In this case, the final explosion was maybe weaker than it usually is, not powerful enough to destroy the entire star. It's like a star wanted to explode but didn't make it, which is why part of the matter still survived. If you ever go into space, don't take off your spacesuit unless you're on a spaceship. Air in your lungs would expand, as well as the oxygen in the rest of your body. You'd be like a balloon, twice your regular size. Good news, the skin is elastic enough to hold you together, which means you wouldn't explode. Small comfort. When something goes into a black hole, it changes shape and gets stretched out just like spaghetti. This happens because gravitational force is trying to stretch an object in one direction, but at the same time squeeze it into another, like a pasta paradox. Speaking of, a black hole that's as big as a single atom has the mass of a really big mountain. There's one at the center of the Milky Way called Sagittarius A. It has a mass like for a billion suns, but luckily it's far away from us. If you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yes, we often hear the sound of spaceships and battles in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you, the sound wave begins to push the first air molecule next to the clap, then the second, third, and so on, until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. So, to carry on a conversation, you'd either need a radio or really good lip-reading skills. Meteoroids orbit the Sun, while the majority of human-made debris orbits our planet. For example, we launched almost 9,000 spacecraft around the world from satellites to rocket ships. Even the tiniest pieces can damage a spacecraft at such high speeds. Galaxies, planets, comets, asteroids, stars, space bodies are things we can actually see in space. But they make up less than 5% of the total universe. Dark matter, one of the biggest mysteries in space, is the name we use for all the mass in the universe that's still invisible to us. And there's a lot of it. It may even make 25% of the universe. Dark energy makes the other 70% of the universe. That adds up to 100, right? Now, let's look at the moon. It always looks at us with one side. This means the moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So whenever you look at the moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. Yeehaw! One myth that turned out to be untrue is that people have never actually been on the moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the moon perfectly. Now, the astronauts didn't need them when they left the moon and tossed them when the moonwalk was over. They left a lot of stuff there, too. They even tossed the armrests of the seats in the lunar module to reduce the weight. Now, counting all the Apollo lunar missions, the total weight of rubbish on the moon is approximately 187 tons, including several lunar rovers, spacecraft debris, 6 lunar modules, and all the experiments left behind. That's like 3 Boeing 737s. Another myth about the sun is that it's yellow. Let's send you into space for this one. You look out the window and it's white. The sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our sun. But young and very hot stars are bright blue. The sun is about in the middle of this spectrum. Oh, one more myth about asteroids. We need to fly a little farther than Mars's orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid clouds. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the moon, so there really aren't that many of them there. To understand the dimension of the emptiness in space, look at the collision of 2 galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here.
Imagine a basketball spinning on someone's finger. A point near the middle of the ball takes longer to spin back to where it started than the spot where your finger is. Earth spins in much the same way. People in the center of Africa are turning at 1,000 miles per hour as the planet rotates, while anyone at the South Pole doesn't really move at all, other than rotating in place. At the same time, we're all moving forward through space equally fast, since the planet is also hurtling around the sun at 67,000 miles per hour. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long, though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. But it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge, but it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, People are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the 5th largest out of the whole lot. There might be a labyrinth of lava tubes on the Moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the Moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the Moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the Moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches. This is the final game of the year. Millions of viewers are glued to their TV screens. The 50,000 people in the stands of the stadium are holding their breath. Everyone's waiting to see who will win this game. It'll decide the winner this year. The loudest fans have stopped chanting. The air's become thick as syrup. It's so quiet, you can hear the heartbeats of the spectators. The pitcher looks at the ball one last time. He's taking wind speed into account and prepares to bring victory to his team. There's the throw! The ball flies like a bullet through the stadium, but the batter's reaction is perfect. And then, the incredible happens. The impact energy accelerates the ball to the speed of light. Okay, let's stop now. I've got to explain this. Nothing in the universe can reach the speed of light if it has mass. For a person, a car, a rocket, even a comet, that speed is out of reach. According to Einstein's general theory of relativity, when an object moves, its size decreases and its mass increases. If an airplane accelerated to the speed of light, its mass would be infinite and its length, 0. It's impossible. But living by the rules is boring, even if they're the laws of physics. I'm sure Einstein would love our idea. So, in our lawless world, the batter hit the ball and it flew at 186,000 miles per second. In just 1 second, the ball would fly around the Earth 7.5 times. Spectators, grass on the stadium, air molecules. Everything around is frozen. Only the ball is moving forward. The small projectile flies out of the stadium, rips apart the atmosphere, and goes into space. And then, the horror, the ball crashes into the International Space Station at full speed. The station has no chance. An object at the speed of light will blow away everything in its path. This story is impossible, not only because a baseball player's bat would break from such a blow. A small ball of leather and rubber will trigger a flash in the center of a stadium that is brighter than the sun. The bright light would be followed by a thermonuclear explosion. When the batter propels the ball to the speed of light, the show begins. The ball moves so fast that the air molecules don't have time to flow around it. The atoms in the air molecules hit the ball and mix with its atoms. Gamma rays appear. They break molecules apart. The air around the batter turns into red-hot plasma. The umpire and the catcher aren't to be envied either. Try to play baseball in volcanic lava. All this happens in nanoseconds. There's 1 billion nanoseconds in 1 second. The eyes and brains of people don't have time to analyze what's happening in front of them. The ball breaks into tiny pieces. Now it looks like a cloud of burning plasma. These are carbon, oxygen, nitrogen, and hydrogen. The stadium is engulfed in plasma and X-rays. For miles around, there's little more than a desert. The landscape resembles the surface of the moon or Mars. Let's take a look at it in slow motion. The bright light comes on first. Then a fireball appears in the middle of the stadium. Boom! The sound of the explosion reaches you. A pillar of fire bursts into the sky and turns into an eerie cloud that most resembles a colossal mushroom. Don't forget about the blast wave. It tears the trees out of the ground and knocks out all the windows in the vicinity. Thankfully, in the real world, such a situation is impossible. The International Space Station has enough problems without baseballs. Here's an American football field, and this is the ISS. The station weighs 420 tons. This is the largest spaceship ever built by humans. The large size and weight of 320 cars doesn't prevent the station from flying 5 miles per second. The ISS orbits the Earth 16 times per day. At this speed, any particle can pierce the hull of the ship or tear off one of its solar panels. There are 2,000 active satellites flying around the Earth. Another 3,000 don't work, but continue their space travel. And that's not all. In space, there are 100 million pieces of debris no larger than half an inch. And we sent them there. At least 34,000 particles the size of your smartphone and more. Even the smallest piece can destroy an astronaut's suit, equipment, or unprotected areas of the ISS. A single screw, flying at 40 times the speed of a jet, is a dangerous projectile, especially in space. Still, the ISS is safe. The padding protects it against impact with small objects. Now with larger ones, it's more difficult, but scientists have figured out how to deal with them too. A security perimeter has been created around the ISS. Imagine a pizza box 15.5 miles long and 2.5 miles wide. The space station is suspended in the center of the box, and its walls are the perimeter boundaries. NASA specialists record every violator of the space border. Scientists calculate the probability of collision. If it's dangerous, the ISS begins to maneuver and avoids the impact. In 2020, the station changed its flight route 3 times. Hundreds of objects enter the Earth's atmosphere every year. Most are burned before they hit the planet's surface. If the metal debris burst through the atmosphere, it'd most likely end up in unpopulated lands or the ocean. Still, things happen. In the early morning of January 22, 1997, Lottie Williams was walking through a park in Oklahoma. In the pre-dawn sky, she saw a bright ball of fire. The woman decided it was a shooting star. Suddenly, she felt something touch her shoulder. It turned out to be a palm-sized piece of metal. The blow didn't harm Ms. Williams. She was the only person on the planet to have been hit by space debris. It was part of the fuel tank of the American Delta II rocket. The probability of getting hit by space debris is minimal. A huge kraken will sooner crawl into your room than a piece of a space satellite hitting you. Debris is invisible in the stream of thousands of small meteorites. They bombard the Earth's atmosphere every day. Most of the rocks are burned in it, and those that fall onto our planet are invisible. The only confirmed case of a close encounter with a meteorite was with Ann Hodges. In 1954, a space rock broke through the roof of a house and hit the woman in the thigh. The meteorite left a hole in the ceiling and a bruise on Ms. Hodges' leg. Let's imagine what would happen if an object the size and weight of a bowling ball flies toward our planet, naturally at the speed of light. In 2 seconds, our space object makes the distance from the moon to the Earth. The ball will crack, but we'll have time to start thermonuclear fusion. This process will release X-rays that will transform the atmosphere into a plasma bubble. It'll constantly expand. There will be no point of impact of space debris on the surface of the Earth. It won't have time to land, but it'll do a lot of nasty stuff. The explosion in the atmosphere will be colossal. The cataclysm will turn part of the planet into a lifeless desert and provoke the destruction of part of the Earth's crust. On the surface, fires, earthquakes, tsunamis, and volcanic eruptions will begin. The sun is the main source of light in our solar system. Light from the star reaches Pluto in 5 hours and 50 minutes. Mercury is only 3 minutes and 20 seconds away. As for Earth, 8 minutes and 20 seconds are enough. If we send a spacecraft to Mars tomorrow, it will reach its destination in 7 months. A rocket that travels at the speed of light will get it done in 3 minutes. We'll hardly ever learn to fly at the speed of light. Most modern spacecraft are powered by ion engines. But scientists are looking for an alternative. For thousands of years, people traveled by ships with sails. Today, this technology is relevant again. Engineers suggest using sails in space. They propose to catch the solar wind with them. A sail is installed on the spacecraft, and photons of light hit it. This creates pressure that pushes the object forward. The most ambiguous idea so far is to create an external pulsed plasma propulsion engine. Its principle is detonating hundreds of nuclear charges behind the spacecraft. The ship will fly forward on their shockwave. Thanks, but no thanks. The most sci-fi way to travel in space is to use a warp drive. In this case, we can fly faster than the speed of light. But first, we have to build an engine that distorts space-time and use this distortion for space travel. So far, this technology can only be found in movies and comics.
Picture this. You're an astronaut, hurtling through the cosmos in your state-of-the-art spaceship. But suddenly, you notice that you're running out of fuel. What are you going to do? Trapped in the middle of space. It's hardly like there's a floating gas station. The good news is that you're not going to get completely stuck. A spaceship will never actually stop after running out of fuel, all because there's basically no atmosphere in space. That's where the popular phrase, "in space, no one can hear you scream," comes from. Sound travels through the vibration of teeny tiny atoms and molecules. In space, where there is no air, there's simply no way for sound to travel. It's the same for our spaceship. Because there's no air, there's also a complete lack of air resistance. Those tiny particles that do exist in space are way too small to reduce the spacecraft's momentum or drag it back. Because of this, most spacecraft actually turn their engines off for the biggest part of their journey. So, don't believe those movies that show spaceships with their engines on all the time. That's completely inaccurate. Unlike vessels in the water, a ship in space doesn't need constant thrust to keep moving forward. Usually, its engine is only fired up for short periods of time. This is not only practical, but also saves money. Fuel is really expensive to transport into space as it's heavy. That's why space probes try to use as little fuel as possible. They need it when they set off from Earth, and then again when they re-enter the atmosphere. It happens when they need to slow down upon their return. While cars and trains have brakes, it's not that simple to bring a spaceship to a screeching halt. The engines are needed to slow the ship down or bring it to a complete stop. This involves strategically firing up impressive thrusters at the front. It creates the needed drag and reduces the spaceship's speed. But this process also requires super high levels of precision. One wrong move and you're toast. Literally. Hit the thrusters too fast and the spacecraft will set on fire as you re-enter Earth's atmosphere at thousands of miles per hour. Traveling too slowly can also cause problems, because in this case, you might miss our planet's orbit completely and move way past Earth. And most spacecraft don't have enough fuel to try for a second re-entry, so traveling too slowly needs to be avoided at all costs. But back to the issue at hand. This basically means that any vehicle with an empty tank will continue traveling at the same speed across space until it eventually runs into something. There's just no other way for it to stop. Wait, actually, maybe that's not good news. If you get stranded, it's pretty unlikely that your buddies over there at NASA are going to organize a rescue mission. This sounds kinda sad, but it does make sense. By the time they set up a new team and find a ship to come and rescue you, you'll have already traveled so far into space it would take them years to reach you. This would also cost a ridiculous amount of money. NASA spends on average a whopping $152 million to launch a ship into space. That's as much as buying 6 brand new top-of-the-range Lamborghinis. Even crazier, it cost NASA about $49 billion to develop and launch the first space shuttle. Unfortunately, once you've left Earth's orbit, it's near impossible that you'll make it back without fuel. That's what actually happened to NASA's Dawn spacecraft back in 2018. On a random day, the spaceship ran out of fuel. This left it completely stranded in the middle of space. It stopped transmitting signals to Earth, bringing an end to an 11-year-long mission that set loads of space records. The spacecraft could no longer generate electricity, as it had no fuel to move its solar panels to point them toward the sun. And to this day, the spaceship is still floating somewhere in space in a derelict state. Luckily, Dawn had no astronauts on board. The spacecraft began to orbit the dwarf planet Ceres, which was the object it was originally investigating. For context, an orbit is a curved path around a star, planet, or moon that an object gets stuck in. But wait, NASA are experts in all things relating to spacecraft, so how did they allow a ship to run out of fuel in the first place? It's actually super difficult to accurately measure the amount of fuel you'll need in space. On Earth, gravity keeps all the fuel at the bottom of the tank, and you can use a float sensor to measure how full the tank is. But this is impossible in space due to a lack of gravity that normally weighs the fuel down. Instead, a common approach is to add an air bladder into the fuel tank that's pressurized before launch to push the fuel into lines. The more fuel is used, the more this bladder expands. It takes up more space and keeps the fuel under the right amount of pressure. This pressure is monitored. That's how they can tell how much fuel is left. As you see, it's a lot more complicated than here on Earth. But say there were astronauts aboard a spacecraft that had run out of fuel. How long could they survive? Well, this depends on how much food and water is on board. NASA usually calculates the extra amount of food astronauts need for their trip to avoid adding extra weight to the spacecraft. But the good news is that this food can technically be rationed, and its consumption can be spread out. That's because astronaut food comes in special packaging to stop it from going bad. There are no refrigerators aboard spacecraft. The food comes in clear, flexible pouches that can be snipped open with scissors. All the food is pre-cooked and processed, so it doesn't need to be stored in a fridge. The only exceptions are fresh fruit and vegetables. These are the only things that need to be eaten quickly, as they will spoil. Today, astronauts also work with nutritionists so they can pick out the foods that they like and will enjoy eating. They can choose from a whole bunch of products, including mushroom soup, macaroni and cheese, chicken, beef, ham, nuts, and even yummy cookies. Shrimp cocktail is apparently a new favorite among astronauts because of how spicy it tastes. Flavored drinks also come in powdered form, just like the Kool-Aid or instant coffee packets you have sitting in your kitchen cupboard. Interestingly, astronauts often report not feeling hungry in space, so it may be easier than you'd think to ration the food. But even if you can make your food last, what about water? Transporting anything into space costs a lot, and water is quite heavy, so it costs even more to transport. For this reason, tanks of water can't be constantly shipped up to space. Instead, astronauts have a really complex water system. It squeezes every last drop of safe and available liquid out of the environment. This involves recycling used water. It means that our buddies in space drink water that's been filtered from old shower water, their breath, the spaceship's fuel cells, sweat, and so on. But don't worry, such water is safe to drink, and it's actually even better than most drinking water that comes out of taps in the US. The water on a spacecraft first goes through a bunch of filters, starting with one that removes particles and debris. Then it passes through multi-filtration beds, containing clever substances that remove impurities. The final stage gets rid of harmful compounds and destroys nasty bacteria and viruses. There are also water reserves in case of emergency. For example, the International Space Station keeps around 530 gallons of water in its reserves, just in case. But what about the air supply? The primary source of oxygen on spacecraft comes from something called water electrolysis. This is an amazing system that uses electricity from the craft's solar panels to split water into hydrogen and oxygen gas. But as we saw with NASA's Dawn, without electricity, it's pretty difficult to aim the solar panels at the sun, which means that the oxygen system would likely shut down. There is some oxygen stored in a pressurized storage tank, though. This is a backup supply designed for emergencies, so it's not all bad news.
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes, and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And, according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
There's only one star in our solar system, the Sun. And all the planets orbit the star. But there are also systems where a planet orbits 2 suns. For example, Kepler 16b. It's an inhospitable and cold place, made of half rock, half gas. But the coolest thing there is that if you visited this planet, you'd see 2 sunsets and have 2 shadows. But astronomers seem to have found something rarer and more bizarre. There might be a planet that orbits 3 stars at once. The GW Uranus star system is around 1,300 light-years away from our planet. It's composed of 3 orange rings. They're made of dust and nested inside one another. In the center of this system, you can see 3 stars. 2 of these stars are binary. It means they orbit each other. The 3rd star revolves around them. Scientists have found out that the 3 rings are misaligned. The innermost ring swings widely in its orbit, and the outermost ring has a tilt of 38 degrees. So, astronomers came up with 2 theories. The first theory says the break in these rings occurred because 3 suns created torque at the center of the entire system. Torque is a gravitational force that always acts toward the center. But sometime later, this theory was written off. There wasn't enough turbulence in these rings for this theory to work. The second theory claimed that this phenomenon could be happening because a planet formed inside one of these rings. A young planet could affect the gravitational balance of the 3-ring system and be the reason they were spread so far apart. There's a specific gap in the dust cloud. Based on its size, the planet we're talking about must be a large gas giant the size of our Jupiter. All space objects have been formed thanks to gravity pulling matter together. If there's even the slightest rotation at the beginning, the spin rate increases with time, especially when an object starts collapsing. That's why all space objects rotate, including dust particles and even black holes. Black holes lose their mass because of a thing called Hawking radiation. Their event horizons are becoming smaller, but this process is very, very slow. A black hole's event horizon is a point of no return. It's like a boundary that surrounds a black hole, and nothing, including light and radiation, can escape once it crosses this boundary. The average black hole would need billions of times the age of our universe to disappear completely. Our home Milky Way galaxy might also contain a supermassive black hole, but we're in no danger. One of the closest large black holes, V4647 Sagittarius A, is most likely 20,000 light-years away. It's safe to observe the effects black holes create from a distance. Problems start when you get too close because of their mind-boggling gravitational force. Galaxies can consume one another, which is one of the ways how they evolve over time. Our closest neighbor is called Andromeda, and it's currently munching on one of its satellite galaxies. In the past, Andromeda ate at least 2 others. Plenty of star clusters are scattered all over this galaxy. Andromeda must have stolen these stars from other galaxies. Scientists have finally managed to identify those stars. They have tracked them back to galaxy mergers that happened billions of years ago. 10 billion years ago, our home galaxy also went through a collision. That's why now its halo isn't like the ones other spiral galaxies have. Scientists first thought it was several small collisions, But then, they realized that most of these space objects in the Milky Way came from a single source. It was another galaxy, Enceladus, that the Milky Way collided with. The Milky Way and Andromeda galaxy might collide, but it's unlikely to happen in the next 4.5 billion years. Neutrinos are electrically neutral particles that are so powerful that they can go through miles and miles of lead, and nothing will stop them. Some of them are passing through your body as you're watching this. Neutrinos get formed both in the nuclear reactions inside alive stars and in the supernova explosions when stars go out. These particles are nearly massless. They need less than 3 seconds to get to the surface of the sun, and then they can reach our planet in only 8 minutes. There's a planet, TOI 1231b, around 90 light-years away from Earth. It's similar to our Neptune. It's a gas giant, but the most interesting thing is that this planet is likely to be rich in atmosphere. The planet is over 3.5 times as large as Earth and a bit warmer than we're used to, 134 degrees Fahrenheit. It orbits a red dwarf star, way smaller than our Sun. But this star is also much older. 1 year on the planet is only 24 Earth days long. Even though the planet is close to its parent star, it remains relatively cold. That's because its star is on the cooler side too. Astronomers think they've seen clouds in the atmosphere of this mysterious planet, and maybe they're even made of water. This star and planet system is moving away from Earth pretty fast. That's why scientists easily detected hydrogen atoms that were escaping from the planet's atmosphere. Yep, that means the planet may even have a tail. A hypothetical white hole is a bizarre space object that is the opposite of a black hole. It's intensely bright and was first mentioned by Einstein in his theory of gravity. Most often, scientists talk about white holes in the context of wormholes. There's a theory that a black hole is like some sort of entry point to a tunnel that takes you through space and time. In this case, a white hole might be an exit located somewhere else in the universe. On the other hand, white holes don't necessarily need to be exits from wormholes. They could also be a slow-motion replay of how original black holes were formed. So, the formation of a black hole starts with an old massive star. After it collapses under its own weight, it usually turns into a black hole. But sometimes, quantum processes don't turn a star into a black hole. Instead, they make a white hole that starts spewing out the matter of the original star again. But so far, this is just a theory. Some planets, like Mars and Venus, have pretty intense weather with powerful storms. And now, an equally strong space hurricane might have come to Earth. It was a swirling mass of air about 620 miles wide. Satellites spotted the hurricane hundreds of miles above the North Pole, somewhere in the Earth's upper atmosphere. The hurricane was raining not water, but electrons. It lasted almost 8 hours before it finally broke down. It was spinning in a counterclockwise direction. It's possible there are oceans hidden under the surface of the moons surrounding Uranus. Scientists have also been investigating the oceans on Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are hidden below the moon's icy crusts. Uranus has 27 moons. 5 of them are especially big. Those are Umbriel, Titania, Oberon, Miranda, and Ariel. Back in the 1980s, when people sent Voyager 2 to get us some images of these 5 moons, scientists found out that they had lots of craters and were made up of ice and rock. Pictures astronomers got then also showed signs of liquid water. It was erupting from the moon's depths and freezing on the surface. One of the most plausible explanations was the oceans under the surface. As a moon moves around a planet, the magnetic field of that planet tugs at it. That is how the moon stays in its orbit. This tug generates an electrical current that transforms into a magnetic field. Such a magnetic field is called induced, and subsurface oceans might be the reason why this induced field can be produced. Saturn is well known for its famous rings, but Neptune, Uranus, and Jupiter also have rings. At the same time, Saturn has something really special we've never seen on any other planet. It's this huge hexagon storm moving around the planet's north pole. Each of its sides is almost 7,500 miles long. That's an area so great, we could place almost 4 Earths inside. According to thermal images, this hexagonal cloud pattern goes down into Saturn's atmosphere for around 60 miles. The planet is hiding behind thick clouds, and sunlight can't get through them. That's why astronomers can't see what exactly is going on there. But there are theories. Saturn is a gas giant. When gas deep inside the planet gets heated, it strays further out. Huge amounts of energy are released along with that gas, which makes it rise, expand, and lose density. The same processes cause hurricanes and tornadoes on our planet. On Saturn, whirling gases come out of a high-pressure zone located within Saturn's outer layers, and these gases trigger a powerful storm of such an unusual shape.
A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. Mathematicians claim white holes might exist. Unfortunately, scientists haven't found one yet. Even if you saw a white hole, you wouldn't be able to enter it from the outside, but you'd notice light and matter leaving it. Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could already be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness in April. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. Our Milky Way galaxy and the Andromeda galaxy, our closest neighbor, are going to meet. But it'll happen in about 4 billion years. When they collide, an enormous elliptical galaxy will be formed. There might be more water on the moon than scientists thought before, and not only on its dark side, but also its sunlit side. This water is likely to come in handy during the already planned missions in the future. Cotton candy exoplanets are particular planets outside of our solar system, also called superpuffs. They have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, these planets are enormous. The Juno mission has noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet. These are 2 kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at a height of 60 miles above massive thunderstorms. In the universe, there are not only dwarf planets, but also dwarf galaxies. They have from 1,000 to a few billion stars. For comparison, the Milky Way galaxy is made up of 250 to 400 billion stars. A storm the size of our planet keeps raging on Saturn. It's called the Great White Spot. The storm has a tail of white clouds, and it encircles the entire planet. The storm occurs every 30 years or so, when Saturn's northern hemisphere tilts toward the sun. At first, the storm is indeed just a spot, and then it starts stretching in length. That's because the Great White Spot is a huge system of thunderstorms. But the main mystery puzzling astronomers is where the storm gets its energy from. Some scientists think it might be powered by the sun. Others disagree. They say the storm's cloud pattern only makes sense if there's an internal heat source that can power the winds. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere.
They're also very hard to find. Rogue planets don't produce light. Neither do they emit heat, which means they can't be seen in infrared light. But not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. The Moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the Moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. Scientists often discover strange things in space. Many of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They aren't the remains of supernovae or a bizarre optical effect. Some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between black holes. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last for mere milliseconds. Most of these fast radio bursts came from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source was a magnetar, just 30,000 light-years away from our planet. Any liquid floating in outer space forms itself into a sphere. This phenomenon also occurs in low Earth orbit. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the Sun. Astronomers saw the star for the last time in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in an extremely bright supernova, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. In billions of years, the universe is likely to expand so much that we won't be able to see any stars in the sky. All planets in the solar system emit radio waves. They're especially strong if we talk about Jupiter. This planet has the biggest and most powerful magnetic field. But astronomers couldn't detect any radio waves coming from a planet outside the solar system. That is, until 2020. The signal scientists recorded came from a gas giant, Tau Bootes. It's 51 light-years away from our planet. Thanks to this signal, astronomers managed to find out a bit about the planet's magnetic field. And in the future, this will help to learn more about what's happening in the planet's atmosphere. Dwarf planet Haumea is further from Earth than Neptune. It's orbiting in the Kuiper Belt. That's a donut-shaped ring of ice objects circling the Sun. Elongated Haumea has 2 moons. A day on this dwarf planet lasts 4 Earth hours. All in all, this space body is rather bizarre. It's surrounded by thin rings that likely appeared as the result of an ancient collision. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf. And the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees Fahrenheit. That's hot enough